All right, so today we're going to be working on classifying rational numbers. So our objective for today is 7.28, extend previous knowledge of sets and subsets using a visual representation to describe relationship between two sets of rational numbers. Okay, so first thing we have is our vocabulary. You have this on your notes, so make sure you are filling them in as I go. Okay, so first things first, the first word, says the blank value of a number is its distance from 0 on a number line. Okay, that A should not be there. So this would be the, let me change the color, sorry. This would be the absolute value. And if you look here, we have a word bank. So the absolute value of a number is its distance from 0 and a number line. On a number line, sorry. So that's when we're talking about like negatives and we're talking about how far apart they are. That's what we're talking about, the absolute value. Okay? And then a blank, a set of positive numbers including 0. Okay? So the numbers including 0, that would be your whole numbers. I'm going to write it sideways because my blanks don't seem to be long enough. Hopefully yours are. Whole numbers, a set of positive numbers including 0. Okay, and then it gives you some examples. And then this says, the third one says a decimal that has a digit or block of digits that repeats without end. Okay, so that one you have a hint in the definition. Okay. And so yes, it would be repeating. Oops. I was thinking ahead. So you can put repeating or you can put repeating decimal. Okay. And where did you use that? And then the next one says a blank, a number that can be written as a quotient of two integers. That one might be a little bit more difficult for you to know, but it is a rational number. Or you can just put rational. I mean, it says a number in the definition. So a rational number is a number that can be written as a quotient of two integers. Okay. And then the next one says a set of numbers, 1, 2, 3. Those are examples that you can use to count objects. So what do you think that would be? Again, there's a hint. Yes, if you said counting numbers, you are correct. Okay. And we use rational. So we have 2 for our last 2 definitions. And it says blank, a decimal that has a final digit. So if it's final, that means it ends. Which of those 2 words would it be, terminating or integers? Terminating is correct. Okay, so it would be a terminating decimal. And then last but not least is a set of numbers that include 0, negative, and positive numbers without any decimal or fraction parts. And that is integers. So integers are positive and negative numbers. Okay, and then also it includes 0, but they have to be whole numbers. So essentially integers are whole numbers and they're opposites. Okay, it cannot have fractions or decimals. All right, so we're going to go ahead and move on to our first diagram. Sorry, guys. And you have this diagram on your notes, okay? So you are going... Sorry, I was pulling your notes in front of me so I can remember it. Okay, so yeah, so you're going to write these definitions on the arrows on your diagram. I wanted to make sure it wasn't... I had left it completely blank or fill in the blank. So the first one would be rational numbers. And rational numbers are repeating or terminating decimals and fractions that can be converted to terminating. So repeating or terminating decimals. And so that's 2 different things. Fractions that can be converted to terminating decimals. Okay, so you would write that on your arrow next to rational numbers. Then you have integers, and integers would be the blue arrow. If you look, the arrow kind of matches the circle it's in. And so integers are whole numbers and their opposites, okay? And so it's, and then in parentheses, it gives you kind of an explanation, whole numbers and their negatives, okay? And then you have whole numbers, which are your counting numbers and zero. So remember, whole numbers include the zero. And then natural numbers, that's just your counting numbers. So for example, your, let me write it in green so you can, so your whole numbers would be 0, 1, 2, 3, and so forth. Whereas your counting numbers would be 1, 2, 3, and so forth. Okay, so that's the difference. The whole numbers includes a 0 and counting numbers does not. Okay, so make sure you copy the definitions, which are right, and then if I like this one that I added the example to it. Okay, make sure you add those examples so you know. Okay, so now let's go ahead and do the let's classify. So we have some numbers, and based on your prior knowledge and the definitions you wrote previously, or the labeling you did on the previous chart, if you see it looks the same, you're gonna place the numbers in the appropriate circle. So we're gonna place the numbers where they go. So our first number would be 0. So where do you think 0 would go? Okay. Okay, so if you look at your notes previously, so where would 0 go? Yes, 0 would go in the whole number. So we would put 0 there. We're done with 0. We have 0.25. So that's a decimal. So that would go in rational numbers. That is correct. And we also know that would go into rational numbers because it could be turned into a fraction. And then we have 1/5. 1/5 can also be turned into, is also a rational number, sorry. And then let's go to -3. I'm going to leave 6/2. I'm going to give you a little bit before we go there. -3, yes, that would be an integer, correct. Okay, so let's do 6/2, and then you can do the other 3 on your own. So if you have 6/2, would that be a rational, integer, whole number, or natural number? Okay, so if you said rational, I see why you said rational. It's a fraction. But if I have, let me change the color. If I have 6/2, can I turn that into a whole number? 6 divided by 2, what do I get when I do 6 divided by 2? 3. That is correct. So because 6/2 essentially when I divide becomes a whole number, that goes in our whole number, and with our whole numbers. It can also go with our counting numbers. But remember, you're going to put it in the box highest up to where it would go, because I know that. So, well, just put it in both boxes. So I put it in both boxes. Okay, so now you have 8, -8, and 7 to do on your own. So go ahead and finish those off. Pause the video. Put those where they belong. Sorry, guys. So like I was saying, pause the video. Put those 3 numbers in on the diagram where you believe they belong. And then come back to finish your notes. Oh, so you come back for your practice. Okay, so that's all for your notes. You're gonna go ahead and complete your practice. You're gonna have 1 of 3 pages. It's gonna depend on your teacher. I'm gonna go over these problems real quick. So let's look at these and see where we can classify them. Okay, so we have 17. So you're gonna check all the boxes that it pertains to. So 17 is a natural counting number? Yes. Is it a whole number? Yes. Is it an integer? Yeah. Is it a rational number? Yes. Okay. And if you're saying, why is that? So let's look at it. So if we look at 17, we would put it in the natural number or the whole number, but well, essentially in the natural number. Since we put it here, you see how natural numbers, the circle for natural numbers fits in the other circles. Okay, then that means that it can be classified as all those other numbers. Whereas if I classify it as a whole number, whole numbers would not be classified as natural numbers because they or whatever I classify as whole numbers, I wouldn't, like 0 would not come back into the natural numbers because the whole number circle does not fit in the natural number circle. Okay. So go ahead and finish off. I know my class is gonna be doing this handout, so you're gonna go through and check or mark an X on the boxes that you think the number pertains to. So like now you would do 0. Would 0 be a natural counting number? No. Would it be a whole number? Yes. And so then you continue going on with the rest. Okay. Once you're done with that, you're gonna go ahead and complete your exit ticket, which is here on the video. It will also be posted. All right. Have a good day, guys.